Angles and angle measure. Couple of words that you're going to want to get yourself familiar with here at the start. Okay, the first is called an angle in standard position, and what that basically means is you're going to start, okay, here in the 0 portion of our angle. I'm going to scooch this over just a little so you can see this a little bit better on this one. Okay. My initial side always starts on my positive x-axis portion, okay, when I'm going to draw an angle. And here's the part that gets a little bit more interesting. My degree measure measures from wherever my initial side is to where my ending or my terminal side, terminal ends, goes that way. But here's the part you've got to watch for. When we're doing a regular rotation, they're always going to be counterclockwise. So if you're given a positive degree angle to find, you're going to start at the initial side, start here where my value would be 0, and you're going to work your way around until you get to that particular angle in a counterclockwise. If you go the other way, that's a negative angle. So you do have to be a little bit careful. But when we start here, we're always starting at 0, and every axis we hit keeps changing my value by 90 degrees. So like when I get to the y-axis, it's 90. If I made it all the way back over to the x-axis again, it's 180, 270, and then I'd be back to 360, or a full rotation, because the circle has 360 degrees. So what we're going to do is, that's what we're basically going to do. Why you have what Chris so lovely put up to is my ghetto protractor, okay? So when it talks about measuring an angle 210 degrees in standard position, I have it here drawn already, but I want you to see where that's coming from. So here, we get to 90 when we get to the top. 180 here, well, how much do I still have left to find?
Oh, geez, math, 30.
30, okay? So to get that extra 30, instead of just winging it, yeah, what I'm going to do is I'm going to line up the bottom of my protractor with the x-axis, and what you do then is you say, okay, I'm looking on the inside part here, I need another 30 degrees. Well, here's my 30 right here. So basically what you would do is you'd say, okay, so there's my 30, I'm just going to keep that in here, and use my straight edge to get the extra 30 I need. And you see it matches up with the one that's already there. So my 180 plus my 30 is where the 210's coming from. And again, I'm not going to get it out and go, ooh, you're 1 degree off, that's terrible. No, but I'm not going to have you just drawing like a 225 degree angle here to make it work. But we're going to get some practice with that here right now. So we're going to skip number 1 because, well, we just saw 210. That's kind of silly to do again. So when we get to 305, and at least for the time being, until you get used to it, I would label each part of my axes here with their proper degree, so you can kind of see how this is going to work. So you start to look at this one, you say, okay, so 90, 180, 270. How much past the 270 do I need to get to 305? Okay, I'm going to need 35 more. So I look and I say, okay, now here's the part that gets a little bit more interesting. Can I just put this down and go to 35 and say, woo? No, because that 35 would be being based off of here. I need the 35 based off of this point. So we're going to rotate. Whichever the last axis is that you're working with, in this case it's the y-axis because I need the 270, I'm going to line this up, and again, this little cross point here that you've got, that lines up with the origin. Then I count off and I go, okay, where's my 35? Right about here. Okay, right in between 30 and 40. So I'll just kind of keep my mark agent here. And then spin it around. It's 2 in 1. It's a ruler and a protractor. And when you go to draw one of these angles, sort of like we had in the example, you're always going to start from your initial side. Start from X and you're going to take a curve going around counterclockwise until you get to your terminal side. So that's how I would draw my 305-degree angle. Always counterclockwise, always starting on my x-axis. Okay? We're going to do a lot of these. So if it's not quite, because keep just telling yourself, I've got to count. Now, I want to do that one next. I'm going to skip 3 for a minute. Because we need to stick to normalcy, because I want to make sure some of you have the regular stuff before we start doing the funky ones. So if we go to 4, we'll come back to 3 in a minute. I'm going to get these labeled again. Again, just till I get used to it. So I start here and I go, okay, 90. Ooh, I'm not going all the way to 180. How many more do I need past my 90? 45. Okay. And again, you won't have to do all this plus 45 and things. You'll get used to it, but I just want you to see if you go back and look at it later. So you're like, okay, I'm basing off of this one because 90 is my last spot that I go to. So I'm going to line up here. Lined up good. I'm going to go find, I need 45 more, so I'm going to stick to the inner ones. Okay, there's my 45. Don't move my writing utensil. Now I got my handy dandy ruler, straight edge here. And again, to draw my angle, I just start from my initial side, which is always going to be the positive side of my x-axis. Just curve until I hit the terminal side. And that's going to be my 135. So, what happens if I get something bigger than 360? Because I can do a full rotation on here, you know, 90, 180, 270. Even if I skip here, okay, 90 more would be 360. Well, then what? I can keep adding and working my way around. So I can add another 90 onto the 360. I can add another 90 onto my 450. Because you'll start to notice, oh, so I can just add 360 to each of these if I needed to, and that would give me the next measure, and it does. So in this case, I'm like, okay, so 90, 180, 270, 360, 450, 540. How many more do I need to get to my... Okay, I need another 40 onto this one. So again, this time my x-axis is my side that I'm working off of. So I get lined up, looking for my 40 on the inside, which is right here. So I get that point made. Now here's the part that gets interesting. You're like, well, now how am I going to do this? Because if I just draw the curve around it the first time, that's not quite going to be the angle measure that I'm looking for. So here's how this goes. I still start here. I start to work my way around. I go through it the first time because to here I'd be at 360. Okay, it'd be a full rotation, but I'm not done yet. So I keep going. Okay, there's 450. There's 540. Now I'm to the end. So if you have angles that are more than 360, you're going to draw the full rotation, but you're going to keep right on going. So you're going to see more curves and more curls the bigger your angle measures get. But that end point, to make that terminal side, I'm still going to do like I do, like we did on number 2 or number 4, where we're just going to go ahead and we're going to draw that in. Okay? Are we okay so far? Because the negative is really not going to change a whole lot. It's just going to be going the other direction. Okay, speaking of negatives, we keep that one in here. Okay, negative 450. Now, when you're going the negative direction, you're going to think of it as we're going the opposite way. So my 90 of sorts, even though it's negative, now is going to be down here. So everything just kind of flips. So I'm like, well, negative 450, if I keep adding, ooh, we're going to end on an axis this time. So this time I don't even have to bust out the protractor because it's going to end on an axis. So again, you always start, even on a negative, you always start on your positive x-axis. That's your initial side. And here we go. So negative 90, negative 180, negative 270, negative 360, negative 450. And I'm just going to color in the negative side of my y-axis a little more so I know where that terminal side is going to be. So if it's on an axis, that's awesome. It's just less work for us. But I still got to make sure I get the curve in there all the way around. Because if I just did it to here, it would only be negative 90 instead. And then one last one. Same idea. Negative. We're doing our counting, but we're doing it the other way. And again, some of you may feel more comfortable labeling these every time. Some of you are like, I really don't need that, and that's fine. All right, so I've labeled far enough to notice. That gets me to negative 540. I need to get to negative 560, so I need another 20 degrees. And since it's the x-axis I'm working with, and above it, get my guide in here, and I need an extra 20. So there's my 20. Just kind of hover with my marker here. And again, I'm not looking for to the absolute degree perfection, but as long as you're close, we'll be happy here. So there's my terminal side. And again, whenever it's negative, we're going clockwise. So we're negative 90, negative 180, negative 270, negative 360, negative 450, negative 540, and stop there at negative 560. Issues with getting our angles. Because when we do the homework, some of it will be looking at a graph and seeing what the degree measure is, and you're actually going to get to do this some too. They're like, no, this is just kind of weird. Like, what sense is this going to take? You'll see in just a second where the application is going to come for this. Okay, bump this up a little bit. All right, so find an angle. I'm going to zoom out a little bit here so we can see everything. So, once I get to here, okay, we are going to find what are called coterminal angles. Okay? And coterminal basically just means as you're rotating, what are some other angles that would end or have the exact same terminal side? Hence, coterminal. They share the same terminal side. To find positive ones, we're just going to add 360 degrees to whatever I have. And if it's negative, I'm going to subtract 360. On the negative one, though, let me stress something. It has to be negative, or you need to minus 360 again. So like if you had a really big angle to start with, like 500, okay, and then you subtracted 360, well, that's still going to be positive. It's 140. So you'd have to do minus 360 again. So just because you minus 360, you're, woo, I'm done. No, not if it's not negative. So that's the one thing we got to be careful with here. But otherwise, you're going to like these. You're like, okay, so how does this work? Well, I got 65 degrees. If I add 360 to that, what do I get? 425. Okay. So that's my positive coterminal angle. Because if I were to draw a 65-degree angle and then rotate 360 right back to the same place, that would be my measure. Okay, what if I minus 360?
95.
Okay, negative 295. Positive and negative coterminal angles. And that's all you're doing on any of these. So like on 8, what would my positive and negative coterminals be? 440 and negative 280. Okay, so we just do plus and minus 360. You're like, ooh, I hope a lot of those are on the homework because that's easy. And it's true. But of course, with anything that we ever do in here, nothing ever stays quite that simple forever because we got to grow a little bit. Hence, you're like, whoa, what is this stuff? Okay, degrees and radians. Okay, you know how when we were doing the graphing before, we always made sure our calculator was in degree mode, not radian. Well, now we're going to start working where we can deal with the radian mode and make this work. So here's the biggest thing to remember when we're back here. Okay, you've got this circle to work with when you're doing homework, but here's the one thing. If you remember two things about this entire radian circle, those are the two you need to know. Pi and 180 degrees are the same thing when we're talking about radians and degrees. 360 and 2 pi, well, it's just double pi, double the degrees. If you know those two things, you can make anything radians that you want to. Because when I'm converting, and we're going to go back and forth, because there are certain formulas that only like radians and certain things that only like degrees. So if we have to make an adjustment sometime, and I've got it again down here, making an adjustment between radians and degrees should be a fairly simple thing to do. So when I'm asked to do it, so to rewrite the radian measure of an angle in degrees, you multiply by 180 over pi. Now you don't have to write the radians part, okay? That's just there to understand we're going to radians, but you'd multiply by 180 over pi. If you're trying to rewrite degrees in radians, you do pi over 180. Okay? So degrees is 180 over pi. Radians is pi over 180. Like, how am I going to remember that? Once you start doing it, you're going to see the obvious way that it kind of goes, oh, duh, okay, when I'm doing these. So all of these r's that somehow ended up messing up my print are all degree measures. Still trying to figure out why that's doing that. So when you stop to think about this for a minute, you're like, okay, 18 degrees, I'm going to put it over 1. Because some of you have fractions are not your friend when you're starting to deal with these. If I want this in radians, because it's already in degrees, if I want it in radians, I do pi over 180. Now here's how I know that to be true. Here, I don't want pi to go away. So if I multiply straight across, I get 18 pi over 180. But of course, we are going to simplify. When you go to simplify, especially if you do it on your calculator, do not include the pi part when you're simplifying the fraction. So we just want 18 over 180 in its simplest form. What would that look like? Yeah, and if you're not sure, you always have the option of just typing it in, of course, and using our old friend from way back, Math Enter Enter. So this would end up being pi over 10. Or you could put 1 pi over 10 if you wanted to, that's okay. But I need to have pi in my solution if I'm putting it into radians. Otherwise, it kind of defeats the whole purpose. So anytime I see degrees, and I'm going to radians, the pi is going to go on top. And then just basically multiply across and simplify the numeric part. So what are we going to get for number 11? Okay. Pi over 30. Okay. Don't let the negatives fool you. It's the same exact idea. Just keep your negative. If I go to that one in its simplest form, what's that going to look like? Yeah, negative 2 pi over 5. Bless you. When I simplify the fraction, I get negative 2 over 5. And then I just make sure pi stays in the numerator. Always. Always in the numerator. And even if I get some big old huge funky angle, yeah, they can really look weird. Negative 41 pi over 9. Yeah. We don't have to use ones like that too often in these. So that's degree to radian. When you see pi already there, that's radian. We want to put it into degree. So when we get to these, it's just the opposite. We want the pi to go away. Well, the only way the pi is going to go away is if the pi is in the denominator. Because if I set it up that way, the pi's will cancel, and then I just multiply across. 720. Now, I'll even teach you a shortcut here in a second. Because again, the pi is always set up to cancel. 5 times 180 is 900 divided by 2 is 450. Whenever you're doing these, what you basically can do, we talked up above how pi equals 180. You literally, in all of these, when you see this, could just do 5 times 180 divided by 2. You can replace the pi with 180 if you're going to degree mode. Doesn't save a whole lot of time because we're doing the same thing here anyway. But it's just something you can think about. Okay, 16, what's that going to look like in degrees? Negative 810. Because again, I'd have 180 over pi, cancel those out, get my degree measure. So you're like, okay, turning it from degrees into radians, radians into degrees, nothing terrible. Okay, it's not going awfully here for us. But what happens when we're being asked to do pi, or radian mode, with the coterminal? Because we remember coterminal is just doing plus or minus 360 degrees. But these aren't in degrees. So do I turn them into degrees and then leave it that way? No. What's 360 degrees in radians?
2 pi.
2 pi. So if 2 pi is 360 degrees,
Divided by 5.
we're going to add and subtract 2 pi to this. Now here's the fun part. I need this. Ooh, my denominator's 5 here. So to turn this into something that I can add or subtract with my 360, basically what I'm going to do is you multiply the number in your denominator times the 2 to get a common denominator of sorts. So if I want to add or subtract 2 pi, well, 2 times 5 is 10, because 10 divided by 5 would get me back to 2 pi. So what I have to do here is I have to take my 2 pi over 5, and we'll jumbo size here so we can actually see. Maybe. That's better. And then I'm going to add 10 pi over 5, because that's adding 2 pi. That's adding 360 degrees, like we do with a coterminal. So that gets me 12 pi over 5. That would be my positive coterminal angle. When I go the other direction, I subtract it. Now, could you put it into degree and then figure it out and then put it back into radian? Yes, but that's crazy and ridiculous. That's too long. 2 minus 10 is negative 8 pi over 5. Okay. And I'm good to go. So you kind of start to see, it's like, okay, maybe. So let's see here. 2 pi in this next one is something over 6. What's going to go in the numerator that I'm adding or subtracting each time here? Multiply these together. 12 pi. Okay, some of you are ahead of me. 12 pi. Because again, when I'm adding or subtracting 2 pi here, basically I'm just making sure I've got the same denominator. So when I go to add or subtract, it works out okay. So here, I've got what I start with for each of these, which is 5 pi over 6. And then I'm going to add my 2 pi, but again, I have to have a common denominator, which is why I did this. So plus 12 pi over 6 in the first, and minus 12 pi over 6 in the second. So 5 plus 12 is 17 pi over 6. 5 minus 12 is negative 7 pi over 6. But again, in this case, the common denominator part is going to be as simple as just multiplying 2 times whatever my denominator is. So if I do that one last time with number 20, what's my 2 pi going to become? 4 pi over 2, because it's just 2 times 2. 2 times whatever that denominator is going to be. So I still start with what I started with. And then again, that 4 pi over 2 is just going to be the part that I add here and subtract here. So negative 3 plus 4 is 1.
90 degrees.
So pi over 2, otherwise known as a 90-degree angle, yes. Negative 3 minus 4 is negative 7 pi over 2. Okay. So if it's in degrees, shoot, just leave it in degrees. If it's in radians, you've got to play the common denominator game. But again, in this case, it's not going to be complex like when we had variables and stuff before. It's just multiply it by 2. You're like, whew, it's getting to be a workout already. All right, one last part. I will hit up the story problems first thing tomorrow. All right, length and area of a sector. A couple of formulas to play with, but they're going to be small. One thing to remember when you're looking for these, I need these to be in radians. If they're not, I need to turn them into radians. Because that's just the, I like to call it Trigg's language of love. Trig loves radians, so we do it the way Trig wants it done. So when I'm looking for arc length of a sector, now you're like, well, what do you mean by arc length? So like if I were to have a piece of pie cut out here, okay, my arc length is going to be how far is this, and we signify that by an S. So to find my arc length, that's going to be the radius times my angle measure. And we always signify angle measures with this symbol called theta. Okay, so it's going to be the radius times the angle measure in radians. When we're looking for the area of the sector, which of course means how much is there to the piece of pie, that's going to be 1/2 times my radius squared times my measure. So, as we were mentioning before, but we'll put them here physically so you can see what they all are. S again is going to be my arc length. R is going to be my radius. I mean, because that's always what R just happens to be. Theta is my central angle. In other words, you know, what's the angle of whatever it's going to be that I'm measuring? And then A is the area of my sector. So when I'm trying to find these, so find the arc length and area of the following sectors. Okay, this one's already in radians. That's nice. So my arc length is the radius times this. Now, some of you may think this is going to be strange, but I have my reasons. I'm going to turn that radius into a fraction, and I'll let you see why here. When I multiply it times the central angle, that's already as a fraction. I don't want some of you thinking, well, I multiply 3 to the pi and the 18, or maybe it's just the 18. If you do it this way, there's no doubt. Because if you multiply straight across then, and then of course, as always, reduce my fraction. Okay, my arc length would be pi over 6. Now again, we're not talking in degrees, so it's not like a 30-degree foot. That's not what we're talking about here. That's strictly a length. The area of that sector, the area of my piece of pie, is going to be 1/2 times my radius squared, so 3 squared is 9, times my central angle. And again, straight across with your multiplying. So 9 pi over 36, but of course I'm going to reduce it.
4.
Where does the 4 go, though?
Bottom.
Okay. So it's pi over 4, not 4 pi, because sometimes you may get an answer that big. And since it's an area, it's square feet. So what happens if they don't give me this in radians right away? You know, what am I going to do? Oh, no. So if I slide just a bit here, I'm going to turn this into radians. So remember, you can do that by multiplying it by pi over 180. So again, we'll multiply straight across. And of course, reduce the fraction because smaller numbers are easier to work with.
3.
So 60 degrees is just pi over 3. Everything else is the same. Okay, the formula doesn't change at all.
3 pi.
It's still going to be, oops, radius, Hardy, radius times my central angle. And like Ben just mentioned, 9 divided by 3 is 3 pi. Okay? Now pi over 3, that would be different. If the bigger number's on top, keep it that way. If the bigger number's on the bottom, it's a fraction. And then my area works the same way. 1/2 times my radius squared, 9 squared is 81, times my central angle. Multiply straight across and reduce that bugger down. So 27 pi over 2 square inches. So, without issue with the story problems here for the time being, which like I said, we will get situated tomorrow. Here is what we are going to be capable of doing now. All right, so we're on 780. So we're actually working our way backwards right now. So 25 to 28, that's just a simple move with some of the angle measures. 30 to 44 even, that's where we're actually, the first part was drawing them. This is changing from radians to degrees and degrees to radians, so that's not going to be anything we can't do. Yep. Okay, 48 to 54, now we're working with some of the angles, the areas, and the arc length. And one last little piece and we'll be set. And then I'm going to put this part in a box, the last part, because the last part's the two-story problems that we will be able to do tomorrow. So again, the goal on this one, since it's Monday, I'll have some answers for this part tomorrow, Tuesday. I need it in my hand to be on time by Wednesday.